Yeah, my name is Trevor Cox. I work at a composite manufacturing facility here in San Diego. We specialize in aerospace composites for engine components.
Perfect. And how do you guys use NC transformers?
So our parts are compression molded, so there's variation in how much the part thickness can be from part to part. And so what we do is we probe the part to learn as much as we can to best fit the actual nominal CAD model to the physical part. What that does is it allows us to position the physical datum structure of the part as well as one virtual datum where it needs to be. Because we don't have control over the molded components that have tight tolerances.
And then what benefits are you seeing in the manufacturing process by using NC Transform?
The benefits are iterative alignments. So like I said before, the part thickness is a variable. Surface finish can be a variable as well. It's a lot like a casting of a metal component, but we're all predominantly composites. So we'll come up with the number of points that are required to best fit those surfaces where they need to be, and then machine the physical datums where they need to be so that we can then inspect the critical components that cannot be machined back to the machined surfaces.
Yeah, now those composite parts, the base material is very inconsistent. What previous problems has NCT solved for you guys?
It's solved the main problem of nonconformance is based on airfoils. Right, the airfoils that we make cannot be touched after molding. The only thing we do is a deflash on the leading and trailing edge of these parts. And so the position of the airfoil is relative to a machine datum structure. So by probing the airfoil and getting that to the nominal location for a thing called N angle is very critical. And without being able to position the machine datum structure where it needs to be, then one of those components back to the engineering drawings would be out of tolerance.
Gotcha. And how easy was it to implement NC Transform into your existing program?
It was great. The folks at NCT, Alex Mitchell and Travis, have been very responsive and easy to get a hold of and very helpful even remotely. But they typically tend to want to come on site, which is great for us because it really aids in training our folks on our facility.
Can you tell us a little bit about what the implementation process was like?
The implementation process was done at that time with one of my manufacturing engineers I'm not super familiar with. However, I believe it was a fairly easy process. I think from start to finish, it was under 6 months.
And can you tell us a little bit about the ease of use?
Yeah, easy use from an operator standpoint is pretty easy. Simply just load the part into the fixture. We have some basic, machining needs to ensure that the part is seated properly. Although NCT is doing the probing with a Renishaw OMP 600 to learn where those surfaces are, and then it'll do an iterative alignment where we'll come back and touch those surfaces again after it actually repositions the part where it needs to match the nominal CAD, and then inspect it again to validate that the exercise of best fit alignment it actually was successful.
Yeah, so it sounds like you guys have kind of standardized your processes by using NC Transform. What changes to the process did the software enable? Did it take away like a cut, measure, cut, or taking the part off and running it over the CMM and checking things and then setting it back up? Did it eliminate any of that?
Yeah, initially, I think early on in the program, many years ago, we were doing that to try to get our NC program to where it needed to be. Since then, that was more of the static programming side of it, right? And then now with the best fit alignment, honestly, the part could be in the fixture a little bit off, and with the best fit, it learns where it needs to go. And the best part about it is on the computer screen, right? It'll tell you what the deviation is in XYZ coordinates, so that you can then look at that and then kind of understand if you're outside of your normal threshold, then something is probably off with your fixture, or maybe the part is that far out, and then you can kind of take it out and not go down that path of machining, and go figure out what's actually wrong with the part before we go try to machine it.
Yeah, so it helps eliminate non-conforming before you actually put a tool into it.
Exactly.
What savings did you guys realize as a result of implementing NCT? Did it help with labor, quality of a part, rework, and eliminate any kind of scrap?
Absolutely. It reduced a lot of scrap, right? If we go and machine a number of parts, we have the lead time from machining to CMM, right, before we get feedback. So that could be anywhere from, one part in a perfect state to, maybe a day's worth of parts or a week's worth of parts. All those parts at risk, right, could then end up on the CMM and then they'd be non-conforming afterwards. So it's really beneficial to minimize the number of parts at risk. And the best way to do that is with the best fit alignment.
Can you tell us a specific story about a product or a part that NC Transform helped you guys with?
Absolutely. We make some exhaust nozzle flaps for the F-135 engine, and these parts are also compression molded, much like the other parts that we make. The uniqueness with these parts is with composites, spring back is basically part of the process, right? There's always going to be some amount of spring back in that laminate, and it can vary depending on cooling temperatures of the tool and a few other factors. With this particular part that we're talking about, there's also a cast metal hinge that is co-cured with the composites. So there's basically two different variables, right? You have the variation in part thickness and spring back in the composite, and then the variation in the casting, and then the co-cured combination then lends itself to even more variation. So the part datum structure from the composite side is very important to learn where those surfaces are and establish those physical datums, and then also understand where the composite surface, the casted surfaces are, so then it can stitch those two together and ensure that all of the GD&T for the tolerancing on the hinge is correct to the laminate.
Perfect, thank you. And who do you think would benefit the most by using NC Transform?
Casting houses, compression molding, probably RTM molding, anything where there's variation in the part surfaces is definitely very beneficial.
If you were to compare a setup without NC Transform to a setup with it, step by step, what does the difference look like on the shop floor, and what has that meant to your overall efficiency?
So without NC Transform, there's a lot of guess and check that needs to take place. Simple machining functions like learning where an edge is and a standard machining setup would be needed, obviously, with our parts. With NCT, you don't really need to do that. It's all automated, right? As long as you have a probe in the machine and you have the NC program, it learns where the part is, it will do the best fit alignment, positions the part physically, on the rotary where it needs to be, and you're good to go.
Perfect. If you were talking to another manufacturer who's dealing with the same challenges you are, someone that possibly is on the fence about buying NC Transform, what would you tell them?
I would tell them that you really got to run the numbers to see the ROI, but I feel confident that it would be a very short return, right? The ROI would be within, depending on part quantity and the value of the part, it would be very quick.